Hi everyone. As we promised the last time that we're going to look at unit vectors in the next video. So this is what we have today. But what is a unit vector? A unit vector is a vector in which the magnitude of the vector itself is just one unit. So one unit on the x-axis and 1 unit on the y-axis. But with vectors, unit vectors, instead of we say x-axis or y-axis, those axes are being represented by I and j. The horizontal axis is being represented by I, and the vertical axis is being represented by j, and they are perpendicular to each other. That's a unit vector. Simple stuff. So let's look at an example here. Let's solve one problem here. Then we can grasp what the idea is. Let's look at this one here. I can number this. Yes, number 1. It says find the displacement of B from A. Displacement of B from A. It means you are starting from A to B. Find that displacement, that distance to say. But here it's given in a vector form. You are told that on the I vector, you have 10I, displacement of 10 units. On the J vector, which is the vertical vector, you have 6 units, which is represented by 6J. And you're asked to find the displacement, displace, S-P-L-A-C-E, M-E-N-T, displacement. Displacement of B from A, that is B from A means AB. You want to find this length here, AB. So you have, this is what you have. You have this one going this way, this one going this way, and then you are asked to find this one. More or less, this is just the resultant vector. You're asked to find AB. And here is 6J, and this is 10I. So therefore, the displacement AB, or the vector AB, they write it in different forms. Some people put 2 arrows, some just do like this arrow. So it depends which one you are convenient with. So therefore, we are going to add these 2 vectors, because for you to travel from A to B, you need to come through this horizontal vector and then this vertical vector. Then you would have traveled from here to here. So which means we have 10I plus 6J. That is the vector AB. If you are asked to find the displacement from now A to B, then the signs are going to change. The signs will change. That's why you see these arrows, they mean something. You're going this way, this way. So come here. If you are now asked to find from B to A, the sign will change. So that is the answer for this question. Displacement from B to A, that is AB. AB is from this distance, B to A, that you are going through this side, you come here, then you just add the X and Y components. X and Y components. So this one is done. Let's look at number 2. Question number 2. this is just explanation. Question number 2. You have this diagram here. A, B, C. And I'm given the vector AB equals 6I plus 4J. And BC equals 10I minus 6J. Find the resultant vector AC. They want you to find this one AC. Or find, like just have done the displacement from C to A. If you want to put it that form. They just use different words. Well, sometimes the procedure is just the same. The method, the solution, sometimes you follow the same steps, but they use different words. These are physics words. So find the resultant vector AC. That is, you're adding the vectors together. What you get is the resultant. You are finding this AC. So let's see. What is AC? So for you to find this one, you must have come through A to B and B to C. So it means we are adding again the two vectors. So now we know that AC is equals to AB, vector AB plus vector BC. AB, vector BC. And we are given AB as 6I, plus 4J. Let's put it in brackets. We are adding here. Let's put parentheses. And BC equals to 10I. This time is minus 6J. That's why you see it slopes. It slopes. It tells you something is negative there when you're looking at figure diagrams, plotting graphs. All right, so let's add. Here, you add the i's together and you add the j's together. You don't just mix everything up like that. So we are having here 6I plus 10I. This will give us 16I. And now you are having minus 4J, plus 4J minus 6J, which means you are having minus 2J. So this is your resultant vector, is C. 16I minus 2J. That's your answer. Let's look at number 3. Number 3. What number 3 says? Number 3 says the acceleration of a particle. Particle could be an aeroplane, could be a rocket, but because it's so small as compared to the space going up, going into space. So normally physics likes to describe them as just particles because it's so tiny. When you look at space, you look at an aeroplane, whatever, no matter what its magnitude is, it's small as compared to the space. So they always say particle, most times say particle. So the acceleration of a particle is given by the vector A equals 12I minus 4J meters per second squared. Find the magnitude and direction of the particle. This is now interesting. So first, let's try to draw the diagram. That will help us solve the problem. The acceleration of a particle. Now we have I. We know I is on the, when we had it here before, this diagram, don't forget, this was our J, and this is I. Yeah? J components. So now, the vector A, let me write it like this. this, so that indicates the vector, is 12I minus 4J, the units meters per second squared. Yeah? So some people write meters second squared. It depends which way is convenient for you. You're still with that. Okay. We now know the I component here is positive. It's 12. Yeah? 12I. The I component, 12I, is positive. But the J component is minus. It's negative. You see here it goes up. Now it's negative, it goes down. So it goes down like this. Minus 4. And now we are asked to find the magnitude and direction of the particle. Again, they use these different words. Magnitude we said before is size. You know, size, something. So magnitude is here. Find the magnitude. They are asking you more or less to find the resultant. Again, this one here. And then and the direction of the particle. So this is 4J, yeah? 4J. 4J. That's what you have. So how do you go about this? How do you go about solving this sort of problem? How do you go about solving this problem? And here they mention find the magnitude, correct? Magnitude and direction of the particle. So this is the particle. It's coming this direction. So the direction, we need to find the direction from here. Let me make it bigger. We have this and we have this, and then we have something like this. Let it go here. It's coming this side. 4. This is the direction because the particle starts from there. And now we need to find is it this way? Come on, yes. This was 12I. This is 4J. So what do we have here? You can see that we have a right angle triangle here. This, we are talking about distances. Although the picture or the diagram tells us that this is negative, because minus 4 here, you can't have a negative distance. We just use those signs for location to locate where the particle is or where something is. But there is no negative distance. You can't have it. Yeah? So this is a right angle triangle. If you look at it keenly, you can see that this is a right angle triangle. So for you to find the magnitude of the particle or the resultant of this particle, let's say A, B, C. Let's label it like this. Now you want A, B. AB is what you are looking for. So what do you get? AB. So AB, this is a right angle triangle. AB, use Pythagoras theorem, squared is equals to AC squared plus BC squared. by Pythagoras. Pythagoras theorem. THRM. Yeah? Pythagoras theorem. This is what you have. It means AB squared is equals AC squared, which is 12. Forget about the I. You're just looking at the units. 12 squared plus BC squared, which is 4 squared. And this is 12 squared is 144 plus 16. This gives you 20. This is 20, 140. This gives you 160. So AB is equals to the roots of 160. Root of 160. Let me use my calculator. Root of 160. Square root of 160 gives you 4 root 10. This is not what we want. 12.64. 12.649, which is 12.65. It's approximately, because we are using integers here, so we'll say we approximate it to 13. That's the magnitude. No units. You are looking for magnitude. It doesn't have units. It's a scalar quantity. Yeah? So that one is done. Now the second part says find the direction of the particle. Again, here you're going to use the trigonometric identities, which I guess you know. We got this side as 13. What I always advise, your calculated answer, if it is possible, don't use it to solve the next problem. The reason being that you might have made a slight mistake. Exams or even assignment, this is 13. But say, for example, you have written it 15. By chance or by mistake, you put 15. If you now want to use this same figure to solve the next problem, part B, then you will get part B wrong, part A wrong as well. So I always advise, if it is possible, avoid your first answer using it on your second solution. So let's look at what we have here. We have 12 and 13. So this is a right angle triangle. We want to find this angle here. So and this angle here, this is the adjacent and this is the opposite. So what trig function do you use to connect adjacent and opposite? You use the tangent. You know the tangent. The tangent of theta is equals to opposite all over adjacent. In this case, the opposite is 4 all over adjacent is 12, which is 1/3. So 1/3, 0.3333. So you are now looking at theta, which is the arctan of this number. Because you want theta, not tan theta. So theta is the arctangent of 0.333. So let's use the calculator again to find that angle. Arctan yes, tan 0.333. It's 18.4 degrees. Just put it here. Theta is 18.4 degrees. So that's the answer. That solves this problem. Thank you for watching. Thank you. Bye bye.